Myself, Naveen Banyera, lecturer in Polymer Technology, Department of Polymer, Karnataka Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, course Rubber Processing Technology, course outcome. At the end of the session of Unit 1, the student will be able to understand raw materials used in rubber industries and their application. Now I am going to present the topic Introduction to Compound Preparation. Compounding ingredients. Elastomers. So here elastomers means there are natural rubber and synthetic rubbers are there. Then comes carbon black. There is a reinforcement. Carbon black will give reinforcement to rubber compound. Next, non-black pillars. These non-black pillars are used in colored products. Next comes anti-degradants, oils and pasteurizers, accelerators and activators, and finally cure vulcanizing agent. Compounding ingredients. Rubbers cannot be used alone as they do not have the necessary properties when used alone. Additives are added for achieving required properties. 1. Cure system, vulcanizing agents, accelerators, activators. Second, reinforcements, that is filler, plasticizers, other process aids. Third, anti-degradants, antioxidants, and anti-ozonants. Vulcanization, or we call it cure system. 1. During vulcanization, the polymer chains are cross-linked, and this leads to prevention of flow and slow elastic properties under deformation. This phenomenon is called curing. Next, as crossing density increases, static modulus, dynamic modulus, hardness increases. Tensile strength, tear strength, fatigue life, toughness all increases with increasing cross-linking density, attains a maximum and then decreases. Next point, hysteresis, permanent set and friction coefficient decreases with cross-linking density. So, ideal cure system. 1. Low cost, second non-toxic, third able to provide fast cure without any cost danger. For dyed rubbers, sulfur. 1. Sulfur is available in rhombic form. Second, sulfur is replaced by elements similar, that is selenium and tellurium, for improved heat resistance of the product. Sulfur can be partially replaced by sulfur donors. Example, TMTD, bismorpholine disulfide. Here TMTD means tetramethyl thiourum disulfide. Third one, phenolic resins can cure dyed rubbers by cross-linking in the unsaturated sites available for dyed rubbers. Fourth one, peroxide. They can cure any rubber. They do not require a double bond. They are used when polymer does not have an reactive site for curing like double bond. Example, EPDM. So it is EPDM, not EPPM, ethylene propylene dimonomers. Silicons cured by peroxide. So for silicon cured by peroxide, example is dicumul peroxide. So DCP, we call it DCP. Dicumul peroxide are generally we are using to cure silicone rubbers. Such crosslink gives best compression set resistance and heat resistance. For next fifth one, metal oxides. Example, zinc oxide can cure halogen containing rubbers. Sixth one is diamines and diisocyanate used as a curing agent. Here diisocyanate are used to cure polyurethane rubber. Sulfur curie is a slow form of vulcanization. Cure time for sulfur can be reduced by adding accelerators. They help curing faster when exposed to lesser amounts of heat. Properties are improved as well as cure is speed up using accelerators without any chance of deterioration in the properties. Efficiency of cure is also increased. Next, classification of accelerators. Accelerators are classified one by chemical groups, that is thiozoles, thiorunes, guanidines, dithiocarbamates, xanthates, aldehyde, and amine condensation products. Second, by speed, ultra fast, fast, medium fast, and delayed action, slow, etc. Third one, primary and secondary accelerator. Primary accelerator can be used alone, while secondary accelerator with primary accelerators. Next, classification of accelerators. Under that, one example, HMT, that is hexamethylene tetramine. It is a very slow accelerator. It is used to speed up thiazole cure for chloroprene rubber. It is a fast accelerator. Second one, DPG, diphenyl guanidine. Slow accelerator, active above 135 degrees centigrade. High modulus, strength and dynamic properties. Third point, MBT, mercaptobenzone thiazole. This was the first highly reactive thiazole to be used commercially in the rubber industries. Very important accelerator, that is low modulus, good dynamic properties, fast accelerator, and has high tendency to scorch, speeded up by thiols, CaO and MgO guanidines. Next, ZMT, that is zinc salt of MBT. Low modulus, fast accelerator, does not bloom and hence used in light colored mixes. And fifth one, thiorunes, TMTD, tetramethyl thiourum disulfide. Sixth one, dithiocarbamates. Seventh one, zinc isopropyl xanthates. Cure at room temperature, good aging resistance. Next, activators and retarders. Activators, in sulfur cure, zinc oxide plus stearic acid is used for improving the efficiency of cross-linking. They help in dispersing the sulfur and accelerator in the rubber. They form intermediate polarity between rubber and the accelerator by forming zinc stearate. Zinc stearate formed inside is useful. So here zinc oxide, this activated zinc oxide activators is widely used in tire industry. So main use of this is to heat stability of a tire, and it will protect the tire from ultraviolet radiations. Next, retarders. Retarder means a class of compounding desiccated scorch retarders is used in some highly accelerated stocks where unusually hot processing conditions are encountered. Next comes pillars. Improvement in property of rubber is done using reinforcement by using pillars. Pillars act as extenders, that is reduce cost. Second, improve processability to improve extrusion characteristics like dies, swell and better surface finish. Third, reduce swelling in oil, example for seals. Fourth one, improve mechanical properties. They can be either inert or active. Active pillars are usually reinforcing, whereas inert pillars are usual as extenders. So here, active pillars. What is active pillar? So we call it carbon black as an active pillar. It gives strength to the rubber. It increases tensile strength and modulus and dynamic properties in the compound. Whereas is a inert pillar, we call it cost reducing pillar. Cost reducing pillar. That is, for example, china clay or calcium carbonate, etc. Next, classification of pillars under that carbon black. Carbon black is an important reinforcement pillar. They are produced through incomplete combustion of hydrocarbon. Example, HAF, that is high abrasion furnace black. SRF means general reinforcement furnace black. GPF, general purpose furnace black. SAF, super abrasion furnace black. So important characteristics of carbon black. There are 5 important properties of carbon black. The one is particle size. It is not partial, it is a mistaken here. So it is a particle. Particle size, particle structure, physical nature of the surface, and chemical nature of the surface, and particle porosity. So these are 5 important major properties of carbon black. Which are all that? Particle size is wrong, partial, it is not partial, particle size, particle structure, here also it is mistaken there, it is a particle, structure, physical nature of the surface, and fourth one chemical nature of the surface, and fifth one is particle porosity. Particle size determines the reinforcing ability of the carbon black. Smaller particle size means more surface area is available, hence better reinforcement. Next, tensile strength and modulus will increase with carbon black loading, and beyond a point they will decrease. Resilience and elongation at break will decrease with carbon black loading. Next, non-black pillars. So here first example is the silica. Second most important reinforcing pillars examples are ground silica, warm silica, and precipitated silica. Next, calcium carbonate. It is known as whiting, basically non-reinforcing precipitated calcium carbonate as lower particle size and used as a reinforcement. Next comes clays. They are hydrated aluminum silicates, hard clay, and soft clays. Soft clays are inert, whereas hard clay are cheap and semi-reinforcing. Hard clay improves modulus and other properties. Clay is called kaolin or china clay. Heating of clay removes moisture and can make semi-reinforcing pillar, that's calcined clay. Magnesium carbonate, it is obtained by precipitation. Refractive index is close to rubber used for transparent product. So it improves extrusion characteristics, hardness, modulus, and compression set. Next, zinc oxide. It's a reinforcing pillar. It imparts mechanical properties, resilience, and flex life, and also it will give heat stability and protection against ultraviolet radiation to the hair. Next, titanium dioxide is a pillar used as a tinting material for white products. So white products we are using titanium dioxide. Next comes talc. It is hydrated magnesium silicate with aluminum silicate. It is useful in heat resistance mixes, electrically resistance products. Next, organic pillars under that, high styrene resin. SPR, styrene prudent rubber containing high styrene content, that is 50 to 85%, are hard polymers. They impart high hardness, tear strength while maintaining low density. B. Phenolic resins. Nolac type resins are incorporated into dyne rubbers and during cure will polymerize into the rubber and form few cross-linking with the rubber. They can reinforce without increasing hysteresis, that is heat buildup. It is also used as processing aid. Plasticizers, softeners and processing aid. They improve processability in mixing, calendering and extrusion operations. They make compound more plastic, that is low viscosity. They are also called softeners. Example, petroleum products from paraffin wax, coal tar. Next, mineral oil. Most commonly used plasticizer, synthetic plasticizer, that is dibutyl phthalate, tricrysyl phosphate. Plasticizers reduce mechanical properties. They also reduce elastic recovery after deformation. Next, blowing agent. So here blowing agent means gas releasing agents. So most of all bicarbonates, ammonium bicarbonate and sodium bicarbonates are gas producing agents. They are required for expanded products. Blowing agent decomposes and produces gases which cause expansion. Gas evolution must occur when polymers are in the plastic state. So examples of blowing agent, DNPT. DNPT means dinitroso-pento-methylene tetramine. Next example, benzene sulfonyl hydroxides. Third example is azotocarbamide, which releases nitrogen and find application where controlled cell structure is important. So these blowing agents are in general used for making rubber balls. So rubber balls in the dies of one part, they are placing a small amount of this blowing agent and placing another part, then they applied pressure in it, then due to that temperature and pressure, that chemical releases gas, that gas will produce the hollow space inside the rubber ball. Then peptizer. Chemical plasticizers, the example is pentochlorothiophenol. Next, they combine with the free radicals formed by shearing and stabilize free radical. Some accelerators like MBTS can be used as peptizer. Next, anti-degradants. They are used to protect the rubber and improve service life. That example, mercaptobenzimidazole. Mercaptobenzimidazole. Under that, anti-ozonants. Wax incorporated in rubbers to form a protecting layer on the product. So wax, it works as a anti-ozonant. So anti-ozonant means it will protect from ozone. So against ozone, this wax will protect the rubber product. wax incorporated in rubbers to form a protecting layer on the product, which protects the product from ozone. Some rubbers, butyl or EPDM, are naturally resistant to ozone. These rubbers are blended with NR or SBR to get that anti-ozonant properties. Next comes miscellaneous materials. So under miscellaneous materials, there are first comes colors. So white and colored articles are obtained through the use of mineral pigments and organic dyes, which can be added as powder or master batch form. Example, titanium dioxide is considered the most suitable white pigment. Next example is a trace of blue dye such as ultramarine blue can be added to minimize off-white tints. Various grades of iron oxides can be used for brown or reddish colored articles. Next, reodorants. So reodorant means here it is scent. So small quantities of essential oils may be added to some rubber compounds to neutralize the characteristics odor or to impart a pleasant scent. So, for example, for this is eraser. Some scented eraser is available in the market. So that eraser it contains deodorant. Next comes abrasives. So abrasive qualities when required in each article as erasers. And erasers here, two types of erasers are pencil eraser and pen erasers. So erasers and polishing or grinding wheels are obtained. By adding fillers such as pumice, silica, carborundum impart these properties. So next we will go for multi-choice questions for session 2. 1. The stearic acid acts as a dash. Option plasticizer, A plasticizer, B curing agent, C bluing agent, D reinforcing agent. So out of these 4 options, first one is correct. Plasticizer. So the stearic acid acts as a sometimes plasticizer. Sometimes it acts as a plasticizer in a rubber compound. Actually, normally it is a fatty acid. It also helps, stearic acid also help against sticking of the rubber compound against the mill roller. Next, smaller particle size carbon black means dash surface area. Smaller particle size carbon black means dash surface area. Option A less, B more, C nil, D none of this. So answer is B more. Third one, tensile strength will dash with carbon black loading. So what will happen when we load carbon black to the rubber? Tensile strength will, what will happen? Tensile strength will dash. Option is here, decrease, B is increase, C remains same, D none of this. So what will happen when we add carbon black to the rubber compound? So tensile strength will increase. Tensile strength will increase along with the dynamic properties, hardness also. Next, fourth one is DNPT is an dash agent. DNPT is an dash agent. Option is packaging, curing, organizing, D is gluing. So DNPT is an gluing agent. It is a gas producing agent. Fifth one, phenolic resins can be dash used in dash rubber. Used in dash rubber. Option A dyeing rubber, option B steam rubber, option D creep rubber. So option A, it's a dyeing rubber. And sixth one, titanium dioxide used to tinting material for products, for dash products. So titanium dioxide is used to tinting material for dash products. Which product? For dash products. So titanium dioxide we are using colored item as I told before. So option A is white, option B is red, option C is yellow, option D is blue. So answer is white. Azo dicarbonate liberate dash and find application where controlled cell structure is important. So again, this azo dicarbonate, this also is a gas producing agent. So azo dicarbonate liberate, which gas to liberate dash and find application where controlled cell structure is important. Option A is oxygen, option B is chlorine, option C is chlorine, and option D is nitrogen. So azo dicarbonate liberate, answer is nitrogen, and find application where controlled cell structure is important. Thank you.